My name is Carlos Castillo.
I'm Angelica Gomez.
And I'm Jesse Melendez, and today we will be teaching you about the applications of exponential functions.
When a quantity is growing or decaying by a constant percentage over equal periods of time, it can be represented by an exponential function where v of t represents the value at any time t. The equation for this is v of t is equal to k times m to the power of t, where m is the multiplier, k is the initial value, and t is the time. So remember, as you do these next two examples, that when the quantity is growing, we add a 1 to the multiplier given, and when it being the quantity, is decreasing or decaying, you subtract the multiplier given from 1. Now let's say that the amount of bacteria present in Carlos's toilet is 200 at 9 a.m. His mom put a chemical to clean the bacteria, and the bacteria began to decay at 18% per hour. So, the equation for the amount of bacteria left at time t can be found by plugging in the given information to v of t equals k times m to the power of t equation. Our equation should come out to v of t is equal to our initial value, which is 200, times our multiplier, but this time our multiplier is going to be 1 minus the 18% because the initial value is decaying. So this is equal to 0.82. So it'd be v of t is equal to 200 times 0.82 to the power of t, where t is in hours. So if we wanted to know after 5 hours how much bacteria was left, we simply plug in 5 to our equation, which would be equal to this. And that's it.
For example, let's say the value of a vintage bike is originally $350 and is increasing at a rate of 4% per year. Now let's recall the equation v of t is equal to k times m to the power of t. Our k is $350 because it's the original price, and our multiplier m is 1.04 because we're adding value to the original price. So v of t is equal to 350 times 1.04 to the power of t. So in 6 years, v of 6 would be 350 times 1.04 to the power of 6.
Hello, sir. My name's Carlos.
Hi, I'm Jesse.
Welcome to infinity, where the limit of options does not exist. I will be your car dealer for the day. So what kind of car are you looking for today?
I want that one.
Excellent choice. Let's go to my office. Well, sir, here we have the 2003 Hummer H1. The retail price for it is $61,397.
I'll take it.
Excellent. Please sign here.
Got one question for you. How much will it be worth in 10 years?
Well, once you drive it off this lot, the value will decrease at a rate of 0.2% a month.
From what we know, Jesse wants to buy a 2003 Hummer H1, and the retail price for that is $61,397. But once he drives off the lot, the value will decrease at 0.2% per month. And Jesse wants to know how much his car will be worth in 10 years. So let's recall that v of t is equal to k times m to the power of t, where t is in months. Now go solve this and then come back and see if you were right. Did you guys really solve it? You guys have to practice. Okay, so we want to find out what we plug in for K and then for M. So K is our initial value, so our initial value is the 61,397. And then M is our multiplier, so we want to change this into a percentage, then subtract from 1. So this will be equal to, our multiplier will be equal to 1 minus 0.002. And that is equal to 0.998. So now we just plug this in, so V of t is equal to 61397 times 0.998 to the power of t. And now we want to turn the 10 years into months because our multiplier is in months. So 10 years is equal to 120 months. And that is our t. So to find V of 120, we just plug it in, and we get this equation. And now you plug that into your calculator, and you should get 48,284 and 98 cents. And that is how much Jesse's car will be worth in 10 years.
There is a virus going around El Rancho that initially affected 20 students, including Jesse. The virus is spreading at a rate of 3% of students per day. How many students will have been infected and end up like poor Jesse at the end of May if it begun on May 1st? There is a virus going around El Rancho that initially affected 20 students, including Jesse. The virus is spreading at a rate of 3% of students per day. How many students will have been infected at the end of May if the virus began on May 1st? Once again, let's recall that V of t is equal to K times M to the power of t. Whoops, excuse me. Now try to really do this problem on your own and not wait for me. Oh, you're still here? Go try this. Practice. Alright, here we go. Since you already did it yourself, right? Okay. Since 20 students are being affected, the initial value, or K, is equal to 20. So K equals 20. Since 3% of the students are being affected per day, M is equal to 1.03. Why? Because the quantity is growing, so we add the 1. So our new equation would be V of t is equal to 20 times 1.03 to the t. So if we want to find the total amount of students infected in the month of May, and we know that there are 31 days in the month of May, then V of 31 is equal to 20 times 1.03 to the 31. So now I have to plug it into our calculator. Okay, and we get V of 31 is equal to about 50, but it's 50.06. Yes. Okay. And that is how many students have been infected in all of May.